My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 543. In this lecture, I will continue my discussion on training multi-layer perceptron. So, let me recall our previous lecture. I request all of you to go through my previous lecture, that is lecture number 542. Before understanding this particular lecture, just let me recall how do you update any weight. What is that? Wkij new equal to Wkij old minus eta into dou L by dou Wkij. What is this eta? Eta is known as learning rate. We will compute the new value by taking the old value and subtracting, of course, eta is called learning rate. There is a lot of interesting theory on how to choose learning rate. We will discuss it in lot of detail in future classes. But the most important thing, if you notice here, is this partial derivative. Which partial derivative? Dou L by dou Wkij. And this is the crux of the discussion, because once if you know how to compute this partial derivative, you can keep update these weights. This is about this update equation, Wkij new equal to Wkij old minus eta into dou L by dou Wkij. That is B. What about C? What you have to do? Perform updates till convergence, isn't it? Convergence basically means you keep changing Wkij till the time Wkij old and Wkij new are almost very, very close, because it is an iterative algorithm. You keep doing this, yes, till the time your old value and new value, yes, till the time your old value and new value difference becomes extremely small, or in other words, eta into dou L by dou Wkij becomes 0. Convergence basically means your old value and new value are very close to each other. Now, the most important step in this is to compute this partial derivative. Which partial derivative? Dou L by dou Wkij. That is the core discussion that we will go through step by step, isn't it? So let's take an example. We have some of these weights here. First, let's take which weight? W311. I want to compute now dou L by dou W311. This is what I want to compute. Now see, W311, it goes into F31. Just see, W31, it is going into F31. Let me show this one here. Just see, W31, it's going into F31 and gives what output it gives? It gives output O31. This O31 is nothing but yi cap. These are same. O31 and yi cap, they are same, isn't it? This O31 will goes to into loss function. This O31 will goes to into loss function. So, if you follow the flow of this, your W311 impacts your O31, isn't it? This W31 impacts O31. Your O31 impacts your loss L, isn't it? I can write this as dou L by dou W311 is equal to dou L by, what is this? Just check. Dou L by dou O31. This is dou L by dou O31, isn't it? Yes, I can write it as dou L by dou W311 equal to dou L by dou O31 into dou O31 by dou W311. What is this particular part? Just let me show it. This one and this one, isn't it? This O31 and W311, this portion. Earlier this is first one, this is second one. Yes, just it is simple and straightforward. As O31 impacts your loss function, that's why you are computing the derivative of L with respect to O31. I can say L is a function of O31, isn't it? Now O31 is also impacted by W311, that's why I write dou O31 by dou W311. Now we are computing all W3. Yes, we would like to compute all the W3. What is W3? All W3 means W311. I must also calculate. We calculated partial derivative of L with respect to W311. In similar manner, I must calculate dou L by dou W321. In that case, I can say we completed W3 in similar manner. First you have to calculate for W3, you have to calculate W2, you have to calculate for W1, isn't it? In this direction you have to calculate. That's what it says, isn't it? Now what is which one we have to calculate? We already calculated this one. Which one? This dou L by dou W3. Dou W311 into dou L is equal to dou L by dou O31 into dou 1 by dou W. This we already discussed. This is I can say, what is this? This is simple chain rule, isn't it? This is simple chain rule. Now let's go back to the just now we will try to calculate. We completed partial derivative of L with respect to W311. Now we will try to calculate partial derivative of L with respect to this particular thing. Which one? With respect to W321, isn't it? Yes. Now I want to look at W321. So W321 also impacts O31, isn't it? This W321 also impacts O21, isn't it? That's what it says. Therefore, and O31 impacts L. Yes, O31 impacts L. So I will write it as, what is this? Dou L. It's same similar manner. I can write this dou L by dou W321 equal to, I can say L is function of O31. Therefore I am writing dou L by dou O31, and also O31 is function of W321. I can write dou O321 by dou W321. This is also, I can say, this is also simple chain rule, isn't it? Therefore this which one? I can write these two are values of W3. What is W3 here? Here W3 means this weight I have, this weight I have. This is W3, isn't it? I must calculate partial derivative of L with respect to this, with respect to W311, W312. In that case, I completed partial derivatives of L with respect to W3. We got W3. We will try to compute the values of W2. Now we will try to compute the values of W2. Let's discuss about W2 means let's discuss about W211. What is this? We already calculated this. Which one we already calculated? We calculated this part and this part. Now we will try to calculate W211, isn't it? Derivative of L. We would like to calculate derivative of L with respect to W211. Here W211 goes into F21. This see W211 goes into F21 and impacts O21. It impacts O21. This O21 goes into F31. Just see, this O21 goes into F31 and it impacts O31. This impacts O31. Your O31 is nothing but yi cap, isn't it? And it goes into loss function and it impacts the loss function. So there are 3 steps. If you speak strictly, how many steps are there? There are 3 steps. What are they? Just you can write it as dou L by, in similar manner I can write dou L by dou W211 equal to, as L is function of O31, as L is function of O31, I am writing like this, and O31 is function of O21, therefore I am writing dou O3 by dou O21. O21 is a function of W112, therefore I am writing like this, isn't it? What is the second function here? O31 is impacted by O21. O31 is impacted by O21. This is second function, isn't it? O31 is impacted by, so derivative of O31 with respect to O21. Your O21 is impacted by W211, means O21 is function of W211. That's why I am writing this. Again, simple chain rule, very simple chain rule for this particular dou L by dou W211. This is related to W2, isn't it? Now, let me consider another weight, which is W221, which is going from F12 to F21. Let's calculate. Which one we will calculate? Let's calculate dou L by dou W221. In similar, it is similar analogy. Your W221 will impact your W221. Your W2 will impact O21. Just see, this W201 is impacts O21. This one impacts this, isn't it? Because it's an input to F21. W21 is an input to F21. W221 impacts O21. This W221 impacts O21. O21 impacts O31. O31 impacts L, isn't it? Therefore, how can I write dou L by dou W21? As L is function of O31, I am writing dou L by dou O31. And again, this dou O3 is O31 is function of O31 is function of O21. Therefore, I am writing this one. Again O21 is function of W221. Therefore, I am writing this one. It's same, similar man. Similarly, I can also write for W231, isn't it? I can also write for W211 you can write, W221 you can write, in similarly you can write for W231. What is W231? It heads from F13 to F21. W231 impacts O21, isn't it? W231 impacts O21. Therefore, I can write this impacts O21. This O21 is a function of W231. O31 is a function of O21, or O21 impacts O31. O31 impacts L, or L is function of O31. Therefore, I can write dou L by dou W231. And all these weights are in W2. We have total 6 weights, isn't it? In W2 we have 6 weights. For 3 weights we have written only for 3 weights, this weight, this weight, this weight. Again, there are 3 more weights. I recommend you to try to do on your own for other 3 weights. Now, let's go to W power 1. W1. Let's take this first example, W111, isn't it? Yes, this is slightly more tricky case. Dou L by dou L by which one we have to calculate? We have to calculate which one. I must calculate this one. We have to calculate this dou L by dou W111, isn't so? If you notice dou W11 impacts O11, isn't it? Just say this one, dou W11 impacts O11, isn't it? But O11, instead of going only to F21, just see O11, instead of going to O11, just see O11, instead of going to only to F21, it also going to F22. So your O11 is going to both into this F21 and F22. Your O11 impacts your O22 through your O11 impacts O22 through this path, isn't it? Yes, your O11 impacts your O21 through this path. Your O11 impacts O22 by this path. There are two different there are two different paths. That's an important point, isn't it? But O22 also impacts O31, isn't it? O22 also impacts, this impacts O31, O21 also impacts O31, O31 impacts L, isn't it? It's simple and straightforward thing. Here we have two paths. If you think about it, imagine, just see, these are the paths, these are the different paths. Imagine I have variable x which goes and impacts the function f, that is f of x. So you have f of x, f of x is function of x. You have x which is also input to g, this is g of x. And now let's assume I have a function h. This h takes f of x and g of x. This is the output. Your h is output of f of x and g of x. Let's say this is how it works. X is an input to f of x and generates an output. X is an input to g of x, generates some output. Here these outputs go into h of x. This is exactly the same situation that we have two paths from x to h. If you notice here, there are two paths to your O31. How many paths? There are two paths. Just see, this is O31 has got two different paths, isn't it? Your O31 has got two different paths. This is exactly same, one path through f of x and other path through g of x. In such case, what is dou h by, just see, these are the paths. This is dou h by dou x equal to dou h by dou f into dou f by dou x plus r. There are two paths. This is first path, isn't it? This is first path and there is another of r. R means what? I must write plus, isn't it? Here it itself is a function of outputs of two other functions. Dou h by dou x is dou h by dou f into dou f by dou x, is that's first path. Dou h by dou g into dou g by dou x is the other path. You take the derivatives of both the paths and sum them up and simply sum them up. This is also a special case in chain rule, isn't it? Just see, I must calculate dou L by, how can I calculate dou, let me say, this k is an output of h. What is dou k by dou x? It is simple and straightforward. Dou k by dou x equal to k is function of h. Therefore, I am writing dou k by dou h. But here I have two paths. This is first one. This is as I have got two paths here. First path is, this is first path, this is second path. Therefore, I am writing this is first path, r. R means plus. This is second path, isn't it? This is the case, isn't it? This the same structure that we have seen in our neural network. We will reuse it here. Just we will try to make use that same rule. What is dou L by dou W11 is dou L by dou O31. What is, why? Because your L is function of O31. Just see, this O31 is function of O21. What is this O31? This O31 by dou O31 by dou 1 W11. We have to compute this. How can I compute this? This is simple. Dou O31 is a function of O21. O21 is a function of O11. O11 is function of W11. Just see this one. Just see. It is simple and straightforward. Just I am giving numbering. Just see. This is 1. What about 2? This is 2. This is 2. What is O31? O31 by O21. That's what it says. And this is 3. O21 by O11. O21 by O11. O11 by W11. Isn't it? In similar manner, there is another path. What is that another path? This is another path. This is dou O31 by dou O22. Isn't it? Dou O22 by dou 11. Dou 11 by dou W11. This I must write, isn't it? Just let me write. Same principle for W power 1, same thing. This is the case. From here onwards, this is first path, this is second path, isn't it? This is first path, this is second path. Now what it says, just if you observe carefully, just you have this summation because you have two paths. Imagine this for a neural network of depth 3. Imagine if you have neural network with 10 layers. It is the same chain rule we have to apply over and over again. Once if you can compute these derivatives, we can quickly update your weights. I request all of you to go through this lecture carefully. I will continue my discussion in my next lecture. There is an important topic known as training multi-layer perceptron. I will continue this particular discussion. If you have any difficulty, please keep a comment. Thank you very much.